Hello everyone, and thanks for joining the session. For us, it's a pleasure to share what we're doing in modernizing the data platforms that we're having in Zurich Insurance, and we're going to as well show you, what is the data stack and the technologies that we're using, how, and possibly a bit of the why. So I will start introducing myself, José Luis Sanchez. I'm head of data solution architecture in Zurich Insurance. Have been working in data industry since the last 15 years. Different projects, different roles. And the only thing is that I am, the data is what we do, and computer science and all of that is my hobby, as you see.
So hello everyone, my name is Gerard. My current role is data engineering tech lead at Zurich Insurance. And so my role is partially coding, which is still my passion. And also I'm managing a team of very talented data engineers. And even that I started my career in MapReduce, Hadoop, in on-premise platforms like Hortonworks and Cloudera. So currently I can say that I'm a cloud lover. And I think that it's the present and the future of all the companies. Mm-hmm. And so if you want to contact me, also you can see the LinkedIn there. And I will hand over to José Luis.
Thanks, Gerard. So about Zurich Insurance, yes, Zurich Insurance is obviously selling insurances. What a surprise! So we are kind of a financial, almost a financial organization in terms of regulation, right? So insurance is a highly regulated industry, And as you see, one of our commitments is that we need to reduce a lot the carbon footprint. That is why LLMs are a bit of a tricky one for us. You know that LLMs are generating a lot of CO2 emissions. Okay, so how it was before all this data revolution in the company, right? So it was mainly really traditional BI stack. So we had data sources, different of them, right? We were doing ETL, we were doing drag and drop tooling, Informatica, all of that, right? We were pushing the data into a standard relational data model in any of the databases, DB2, SQL Server, Oracle, you name it, right? The traditional relational ones. We were doing after another time ETL, right? And then eventually it was pushed into our data warehouse like structure, right? It was good for for the business. Why? Because they had really clear, right? What was the stack? We have this monolith. We have this thing that we run once and again. However, there were some problems, right? The problems is that every time that we have a project, every time that we have a new data challenge, every time that we have a new, you name it, right? Requirement from the business, we were doing the same once and again, a copy of a copy of a copy. Good things still. The project managers were really happy because they were all the time doing the same, right? Hey, you know what? We have this database, we have this ETL, we have this visualization in MicroStrategy. Oh, great. Now, the problem is that we have been replicating this a lot of things across the organization. And Zurich is a federated organization. So it means that, yes, we belong to the group. We provide the standards, we provide the frameworks, but in the end, the countries are as well having their own decisions about what they can do and what they cannot, right? So then we were having different infrastructure replicated once and again, and as well the data, right? The data, when we say, hey, data lineage is super easy, super fancy, the problem is that when the services and the servers are spread around the world, the things are getting tricky, are getting really, really tricky, right? So then on data warehouses, right? We probably all know what is a data warehouse. Relational is really good for BI, is really good for asking the questions to the data mostly on the past. Challenges is that, okay, no support for video.txt. This is a bit the buzzword because there are maybe not in the enterprise those many use cases still around the video text for sure. Data science and machine learning. It is always, this is a tricky one, right? Because I would say is that no support for data science and machine learning inside the platform. But obviously, you could always retrieve data from the warehouse. That's no brainer. And then limited support for streaming. That was a real problem. Why? Because if we remember, when we write into a table, and when we write into a relational database, the table gets locked, right? And then you cannot write. So for real time, not being able to write usually is a bit of a problem. Okay. So then we moved into a less BI world. So we moved a bit out of the drag and drop. Why? Because it was really useful, but still not that flexible. Okay. So that was one of the main reasons. Then we moved to the cloud, and we started doing a lot of data science and advanced analytics. I mean, fraud detection, pricing, risk accumulation. I mean, you name it, right? And then what we went is to a big data platform that we were running in Hortonworks. And I mean, we were designing or we were doing the traditional thing, right? So we had a lot of different data sources. We were putting that together into the same platform, what we called a data lake, and then a European data lake in that part, right? There was another in America, do you remember? So then we were just deploying the use cases on top. Okay, so we had a number of machines on-premise that were super costly to maintain. Well, I still remember one day when they called us and said, you know what, one disk drive is broken, 6 months to replace, right? That was a bit of a problem. So, but who cares about a disk, right? So then we just as well moved all this to the cloud. Well, and before that, a data lake, we said we put all the data together, poor BI support. What it means, you can run queries in a data lake, right? In the good old ones. The problem is that the engine that we're doing the joins and the transformations and some of the operations was not really optimized for that, right? You can run a query, still in Hive, it will take 5 minutes, no problem, you go for a coffee, you come back, and then just check the results, right? That is not what business wants. So then it is also true that the governance is a bit complicated. Why? Because we have files, we have data, we have tables, we have videos, we have audio, all of that, right? So it makes a bit the governance a bit complicated. So then we came to a conclusion as well, more or less the same like Databricks. Why cannot data warehouse and data lake be, let's say, collaborating, right? So I mean, there are some examples, right, about the breakfast supremacy, right? And then what we took the approach of the data in a different way. So we are not going to do a data platform we are not going to have a data platform to do projects, but we are going to design a platform to share data, right? And share data doesn't mean that, again, insurance is regulated, right? So that doesn't mean that anybody in the organization is going to be able to see the data of the claims or the pricing. No. That means that whoever should have access by default to the data should be able to play with that data. That is what we mean with sharing. Okay? So, and obviously the world is kind of complex. So we still have a data lake that we will put all our data. And then comes Apache Delta, or Delta Lakehouse. Why we like Delta? I will say 3 main features. The main one is the time travel, right? So then with Delta, we have data versioning. So we can see the data as it was loaded before. We have an audit track. These rows were updated. These rows were inserted. These rows were deleted. We have all of that, the time travel. So we have as well that is open format. So we will never lose the control of the files, right? Because sometimes we hear with some of the services that, oh, you know, you lose the control of the data. The data maybe it's in a proprietary format. So you know that is something that will never happen with Delta Lake. And last but not least, it's happening a lot of cool features. My preferred one is one that is called shallow clone, that is allowing us to create tables without actually moving the data. Which, for cost reduction, imagine how good it is, because you can have still all the layers in the lake with different curation, but still having the data in only one place. So we avoid the copies. So please avoid copying wherever you can, right? Always is a problem, copying in different aspects of life. So then comes a Unity Catalog on Databricks that we use for centralized access, especially what I call this Unity Catalog is like a hive mind of the Databricks workspaces, because when you switch or you adapt or you link one of the workspaces to the catalog, then it gets into the network of those workspaces, right? Then what is also good is that Databricks is providing us a high speed and super optimized consumption layer in SQL, what we call SQL Warehouse, right? And well, so that is what all the use cases that we are deploying on top, right? So you one platform to rule them all. Okay? So then on top of that, that is more on the technology, in Zurich we came to, just designing this complete data platform, general purpose, that have mainly 4 big components. As we see at the bottom is the Lakehouse as a service. That is where we are ingesting all the data, we are doing a bit of the curation, and we are preparing the data for the next level. What is the next level? 2 big blocks. Data governance platform, we are going to manage the data. We are going to look for the owners. We are going to look for the business terms. We are going to be for the semantic meaning of the tables. You know, all of that, all super exciting about data management. It was a joke. So, and then the next one is the data sharing platform. Is that when I have the data ingested, I have the data ready, how the people are going to use that? That's an interesting question. The data is in the lake. Why the users are not going there? Because they don't know. Right? So we need something extra to make their life easier, right? And then we have especially around the data marketplace that we're working on that, and the data sharing APIs, right? So we have the data, right? And then it's easy to integrate with other things. Okay. So in terms of technology, we run every data ingestion we run on Databricks, right? We have built, and now it comes another slide as well, we have built an automated ingestion framework that is allowing us to connect to the different data sources and retrieve the data. And what means retrieve the data? I have a database, I go and I bring it all to the Lakehouse, right? And I bring it all in Delta format. So it's not that it will be one data will come in CSVs, other will come in a PDF, Excel, no. Once we put that in the Lakehouse, everything is in Delta, so that we can manage all the data together the same. So the next one is the ETL that we have done. We are using DBT. That I will explain another slide why, but the reason is that essentially it's super lightweight, it's cloud agnostic. We will explain, and Gerard will provide also some use cases and examples, right? And the data storage, we're using both clouds. We're using Amazon and we're using Azure. Google still not is in scope for in the company. And then the consumption, right, that is the data exploration at raw level, we are using as well Databricks in the shape and form of notebooks, okay? So then if you see there is still one that is Cloud Warehouse, that is where we are going to shape the data in a relational model, right? And then we use Databricks SQL on top just to provide this layer and the access, right? The others are still in discussion. And in the top right, you see as well that we use Databricks for data science. And after today's announcement, maybe we can think about LLM and all of that, but we'll see. Right? Depends. So then I'm going to explain a bit in detail how it works, the Lakehouse as a service, how we have built and how we have architected. So we have different data sources. As I said, we have the ingestion pipelines built in AWS and in Azure, the same code. That is what we like as well. Databricks is sitting in the middle of the different clouds, so we don't have to go and code once and again. We just have the same code. We deploy it to the both places. And then we do the orchestration with Apache Airflow. That also is super useful in this kind of, let's say, cloud agnostic scheduling. The transformation, as I said, we do in dbt. And then we push all the data that we ingest, we push that to the different ADLS and S3 layers, right? And for that, because of the regulation or because of data residency challenges and requirements, we're having local lakes. So it means that we have one lake for UK, another for Germany, another for Australia, another for you name it, right? Mainly, why? Because we deliver that infrastructure usually in the country, if there are specific regulations. Right? If not, we do in EMEA. If not, we do in US, depends. Okay? So the communication and how the data is flowing and is being accessed through the clouds, we are using Unity Catalog plus Delta sharing, that I will go in detail in a second. And then for the consumption, as I said, we use Databricks SQL and dbt for the transformations. Okay? So easy peasy. And I will go on, well, the bronze is still on the lakehouses. We do a bit of transformation, so it means that the silver is still the normalization, a bit of aggregation as well sometimes, depend, cleaning. We do on the, as well on the lakehouse side. And the gold is where the business logic and the data is ready to be used by the business. Is that what we put in the consumption piece, right? It's more a relational, most of the times it's relational model that we build on top. Okay, so with this said, I'm going to explain a bit really fast how we have set up the multi-cloud Unity Catalog thing. Before Unity Catalog, it was almost impossible. We tried, we were almost, but then Databricks said, hey, you know what, forget about what you're doing. We have released this Unity Catalog. I said, oh gosh, couple of months of work to the trash, no problem. And yes, then we figured out how to do it, right? So we have on the left the Lakehouse ADLS version 2, where we have our containers and we have the different layers of the lake, right? We have the raw, we have trusted, where the data is curated a bit, and we have secured even when it's anonymized, okay? So that is connected through this Databricks Access Connector, and that is all connected into the hierarchy of elements that are bringing the Unity Catalog, right? So, you know, Unity Catalog, one per region, and in one catalog you can have different meta stores, all of that, right? And then I don't want to forget about my good old friend Hive Meta Store, that it was common for the both clouds, okay? So I will switch to the, if you see on the bottom right, that is putting the Delta Lake, the Delta sharing, and that is the point where we are sharing the data with AWS. So essentially we say this table that is in this catalog, is in this region, whatever, is going to be shared with another recipient, right? And that is where it came the arrow directly to the Delta sharing in AWS. So now, some things to take into consideration. It's not magic, that arrow, okay? So that arrow implies a lot of things. Implies that firewalls are open. Implies that there are connectivity between two clouds. Implying that the permissions are there. So you know what? I mean, PPT compiles everything, but later on, I mean, to bring that into reality, it's a bit of a challenge, especially when we're having an environment in the cloud that is secured, right? If everything is open, no problem, happy flower, rainbows, unicorns, I connect, everything works. The reality in enterprise is not that bad. Okay, and then the same thing, right? So we have the S3s where we have the data stored, and we have the Databricks Access Connector that in S3 is called IAM role, okay? And then the same. And the thing is that the Hive Metastore I said is the same. It means that if I do a show tables in any of the spaces, I will see the same data. I will see the same metadata. The data, it's only if the firewall is open, okay? So what I was saying is that also we like or we choose DBT, many reasons. The main one is because it helps us to execute the code in any lakehouse directly. So we say this code that is stored in DBT is going to execute in this SQL warehouse, okay? If the same code is going to be executed in another SQL warehouse, doesn't matter if it's another cloud, it will still work, right? Because it uses a Databricks engine to generate the tables, to generate transformations, all of that, right? And then the storage and all the rest of the infra is provided for by Databricks. So that is something that we really like. Okay? So with that said, just going to say that, well, with Delta, DBT, and Databricks, I mean, we are tackling most of our challenges when we are when the business comes with a problem, we want to see this data, we want to do this analytics, we want to have this report, all of that. I mean, we're solving most of them, I would say more than 80% with this stack. Okay, there are obviously some exceptions, but most of the stuff we are doing with this. And with that said, I will just hand over to my beloved colleague Gerard. So,
yeah, hello. So in my case, I will explain how it changed in the life of the data engineer and how we change from the use case specific infrastructure and code to this data modern platform, okay? So this is how we start some years ago, right? So we had dedicated projects where each project has its own infrastructure, its own code, that engineers were building the ETLs. These ETLs were connecting to the different Azure systems, like you can see SQL, Excel, SharePoint, everything custom, also the custom transformations, and all of this was finally put in a data model in some tables where the business analyst, business intelligence tools, or data scientists could consume, okay? So here you can start to see that this, at the end, the data sharing was difficult, right? So at the end, we were creating some kind of silos. Obviously, we're following best practices, right? So we're following all the open source standards, like small function, naming convention on the functions. The code was properly documented with external documentation also. We were using Scala and Python with all our preferred IDs, which is IntelliJ and PyCharm. And also, we were having all the code in version control. In our case, we're using Git, with also the same, with proper methodology, mostly using the Git flow. Also, one important part that we have is the CI/CD. In our case, we are implementing the CI/CD in Azure DevOps, where mostly we are always creating two pipelines. Here you can see both of them. The first one is the validation pipeline, where basically it's triggered automatically when we do any pull request. And automatically, we'll do all these steps that you can see below. It executes the unit test, it calculates the code coverage, it does security checks using Veracode, and also it checks for the code quality using SonarQube, together with some security extra checks. And the other pipeline, the deploy pipeline, is a pipeline that we'll be using for deploy to any environment. So here, for example, you can see how a Python project, it's packaged as a wheel, and it's deployed to a specific cluster in a specific Databricks workspace. So, okay, this was all good. The code was good, following all the best practices. It was quite good performance, but were the clients ready for this way of working? So basically, whenever any project was finishing, we were going to the clients, we were doing knowledge transfers, just to let them know how the application was working, and also if they would require to do any minimal change, they could do it in their own. But what happened, that in some cases, the client found that too complex, and they were not able to do small changes, or even in some cases, they were trying to do these small changes, and this was becoming fires, in details that we had to solve very quickly because production was failing, right? So we were seeing that this high-code approach, maybe it was not working for all the pieces of the project. So we start to move to a modern data platform and a new way of working. Okay, so what we did first is we decoupled the extractional load from the T, right? And we did this using the product that Jose Luis already mentioned, the ZIDP, which is still high code. So here we are still using Scala code. But this product is the one responsible for ingesting all the sources that I mentioned before to raw data, so what we call the bronze layer. But now the projects doesn't need to do this code anymore, so they go there, just configure in a simple way the ingestion, and they only need to say what you want to ingest and how you want to ingest, and the product will do for you. This is also generating this Lakehouse platform, where we also have solved the data sharing that before, it was kind of difficult. Okay, so we have solved the extraction and load, but we are still needing the transformation. So we have the raw data, and we still need the gold data. So here is where dbt comes to the picture. Basically, it's a tool that allows us to develop, test, document, and deploy any application to transform the raw data that it was ingested by ZIDP to the data set, so the gold layer that any stakeholder can directly use. Also, the dbt, what it does is it sends, it creates the workflow, and it sends the code to execute the different data platforms. So here you can see some of them, like Redshift, Snowflake, Databricks. Even that Databricks is our beloved one. So we can use this tool to rule them all in other technologies. Okay, so here is how it looks like dbt Cloud, the user interface. And basically, I will show you some of the features. So one of the important one is the version control, right? So we don't want any tool without version control. This is mandatory for us. Also, it's low code, so it's using SQL. So now this has reduced the complexity. So now it's easy to maintain and easy to develop, right? So it's much more simple than Scala or Python. Also, it has a command line if you want to trigger any step of the workflow. And also, it has the data lineage, which is, for me, the most important, or what I preferred more, which it allows you directly, automatically, to build this data lineage with all the relationships. So if you want to execute any layer, so DBT will know automatically whatever needs to execute before in order to have this final layer with the proper data. Okay, so was everything easy? So no, always we have challenges, right? So here you can see the biggest challenge that we have with DBT is that basically DBT, in order to generate the code, so first it will ask for the metadata in the Databricks workspace. A Databricks workspace will return the metadata, and then DBT will compile and send the job to execute. What was happening? That in this initial configuration before Unity Catalog, so the Databricks workspace was connecting to our external Hive metastore, which was Azure SQL, and only this step of retrieving the metadata was taking like 5–10 minutes in databases with a huge number of tables. So obviously, this was not acceptable for some projects with strict SLAs. The good news is that Databricks announced and released this Unity Catalog feature that we implemented here in Zurich, and we changed from these 5–10 minutes to just seconds. So we can say that the Hive metastore is dead. Long life to Databricks Unity Catalog. So if anyone is using DBT, I would recommend to directly use Unity Catalog because the difference is amazing. Okay, now I will go through some use cases, how we have implemented this platform. So the first one is investment management. So this is one of the important departments on actually any insurance group. And here in this use case, the different stakeholders, the front office, the middle office, back office, so they were creating their own reports, accessing the stocks and transaction data. And each of them, they were having some Python, some manual thing, in some Excels, and each of them, they were creating their reports. Obviously, this was taking a lot of time after to reconcile all these different reports. And some of these reports were shared with the regulators. So that means that there was a high risk that we could do mistakes, and this could lead to fines, right? So this was something that we should solve. So okay, this is how we solve it. So we introduced basically the platform that we mentioned before with ZIDP for the ingestion, then DBT on top of Databricks to do this transformation. And then we are using Databricks GDBC, and where the different stakeholders can connect and generate the reports. So basically, in this way, we have removed the reconciliation time. We have reduced the complexity of maintaining these 4 or 5 ETLs to only 1. And also, we have reduced the risk to these mistakes that could lead to the fines. So we have only one source of truth. Here you can see how it looks like the code. Again, some interesting things that you can see here on this selection. You can see that inside models we have different folders. Actually, these are the different layers that we have. So this is also a thing that you should follow, because if you just create a SQL with everything there, so it will be unmaintainable, right? So here, basically, you can see that you can structure the code in different layers. In this case, staging, transformation, data mart. And also, you can see it on the data lineage, also these different layers. Like the green boxes are the ingestion, the ZIDP tables. Then we have a set of blue boxes, which are the staging layer. Then the purple one, which is the transformation layer. And the last one, which is the data mart layer. And here is the syntax to let DBT know, OK, these are the dependencies that that you must have on this specific layer. Okay, another interesting use case is that, we have some client that is calling our call center, requesting some information about some of their policies. Okay, so what was happening? That because of Zurich is basically absorbing other companies, or just because they have new products and they have built another system and kept the legacy one. So when the call center was trying to find the client on the different sources, for example, on the source A, it couldn't find the customer because instead of Jonathan Willis, it was John Willis. So it was very difficult to find that person on that source. Or for example, in the second case, maybe we had a Jonathan Willis, but you can see that the address is different and the date of birth is different. So actually, even that the customer was retrieved, it was not the same person. And maybe on another custom source, it was found, right? But here you can see that we have a problem. So we would need a system that would identify uniquely the customer across the different source systems. So this is the flow that we have designed, so where basically what we are doing is we are ingesting all the sources first. After we have ingested the data, we have some standardization because the name of the address could be different in the different sources, or the name or whatever. So we have this standardization, and also we are applying some data quality checks. Finally, when we have everything aligned, is where we are applying the customer match algorithm. This customer match basically using the name, the address, the date of birth, and the national insurance number. If we would have the national insurance number, then we don't have issue, right? So we have the national insurance number, which is a unique ID, and we could match. What is happening? That in some countries, you can open a policy without any ID. So you only have the name, the address, the date of birth, this kind of information. So we would need to build this algorithm to solve this and create this unique ID. After we have the unique ID, we create some views like the customer details, the policy list, the policy transaction, the policy details, where we have all the information merged from all the sources pointing to this unique ID. After that, we are pushing this information to the call center, so they have the data available. So how we are building this customer match algorithm, we cannot do it with SQL, right? So sometimes SQL is not enough. The good thing is that DBT is no SQL. It's not only SQL. A part of having SQL, so this is the infrastructure that we have, the platform. So we have ZIDP still for the ingestion and for the transformation. So now we are using SQL together with Jinja. This is an extension that DBT allows on top of SQL. And also, it allows to use Python. So we have been able to build this framework, this customer match algorithm in Python. So this gives us a lot of flexibility because we could basically implement almost everything in this Python step. Obviously, we don't have to fall in the temptation to do everything again with Python because otherwise we are again on the initial picture. But for specific things that you cannot do it with SQL, so you can also use it in Python and embed it on the same workflow. So here I have put some examples just to show you how it looks like Jinja. So basically, it's like on top of SQL, you can put a set to set variables. You can create fors. You can create ifs. Something like the PL SQL that we had on the past. So this gives the extension to SQL to do something like this. And then where the magic comes is actually the Python part, where now we can create a wheel. We can have our code, create a wheel, and then deploy it to some cluster. And just with this import statement that you have there from Databricks.customer matching import customer match, we're importing the customer match algorithm, and then just with these few lines, we can use it in our DBT project. So here is how it would like all the workflow. So here you can see all the workflow. For example, for the view of policy list. And here you can see a lot of steps. Some of these steps are SQL, and some of the steps, particularly the customer match, is a Python step. So You can build a workflow, and you can say to dbt, OK, execute me the policy list step, and also execute anything related with that. And then dbt will execute in parallel if it can execute in parallel. So you can see that there are some steps that can be executed in parallel, so dbt will execute in parallel. In some cases, if it's sequential, it will execute in sequential, and obviously in the proper order. So in one single tool, we are able to do all this complex logic and manage it very simple. So as a summary on this journey, so what we have seen is that dbt has solved the transformation part of the ETL or the ELT, and Databricks, using the high code, is providing the extraction and load part. And with that, thank you to everyone.